Hi, everyone, and welcome to our webinar on leveraging AI for Earth observation applications. My name is Jack Kuhr, and I'm the research director at Payload. We have a very exciting webinar today on a very relevant topic, a question and topic that we get a lot from the Payload community. So it's going to be a really, really interesting hour-long conversation. I'm sure you guys are going to have questions that pop up. So there is a chat box, Q&A chat box below on the Zoom call that you feel free to just plop questions in there, and we will try to get to it real time. So with that, I want to quickly go around and introduce our panelists today. And then I know Satellogic, who's our sponsor today, is going to present a cool presentation on AI and AI in action with their Earth observation platform. So with that, first, maybe Alison, I'll kick it over to you, and if you can give a intro on yourself and NVIDIA as well. Thank you.
Thanks a lot, Jack. Hopefully everyone can hear me all right. So I've been with NVIDIA for just over 9 years now. So 2015 I joined, which was pretty much when AI was really starting to explode as well. I'm senior scientist for what we class as global AI, so that covers on Earth, off Earth, but also in world. That's simulation where a lot of prototyping goes on today. NASA's got a huge background from doing a lot of things in sim, but we've taken that to 3D level right now. So I cover pretty much everything in space, but it's all connected. The ground segments are huge businesses. Folks at Satellogic and Maaz at Ageo can explain as well. Great to be here.
Great. Maaz, why don't we go to you next?
Sure. Thank you so much, Jack and Alison. So Maaz, founder and co-founder and geospatial engineer at Ageospatial. It's a young Swiss startup that's trying to make geospatial location data accessible through GeoAI, through language models, through vision language models. So we're having a lot of fun with those new things that are coming out. And we're very happy to serve federal agencies as well as some other partners. And yeah, very excited to be here and being with all those talented people on this call.
Yeah, thanks. I definitely want to get to that vision language model comment that you made at some point today, but Gerardo, maybe we'll kick it over to you for an intro as well.
Thanks, Jack. I'm Gerardo. I'm today Chief Innovation Officer for Satellogic after doing many things in these 14 years since we founded it with Emiliano here present. So we're both the co-founders, and excited to be here to finally show what we've been working a bit under the table, like without not many people knowing. So we'll see where we go from here.
Great. Thanks. And Emiliano?
Thanks, Jack. Yeah, I'm Emiliano Kargemian. I'm the CEO of Satellogic, along with Gerardo, one of the co-founders of the company. I think we want to get right into it. I wanted to give maybe take a step back and maybe give a little bit of a background of what we're working on in terms of AI, at least on the ground, because I'm sure with Alison we'll talk a lot about AI in orbit and the stuff that we've been doing there and that other people is doing there. But, in Earth observation, I think if we look at the bigger blockers for mass adoption of Earth observation in mainstream applications, I think the biggest three things are, the cost of the data, the availability of the data, and how easy it is to use it, right? In terms of cost, high resolution imagery has been historically very expensive, and low resolution imagery, like we get from Sentinel and so on, it's essentially free to access, but it has very limited uses, right? Just because you don't get to see enough level of detail. In terms of availability, if you have to task satellites to go take imagery, you're always competing with other customers for the satellite use time. So we're competing, targets are competing amongst themselves. You really cannot make sure that you have the data available when you need it for your applications. right? So I think both cost and availability have been two of the bigger bottlenecks. At Satellogic, what we're building essentially addresses initially those two things, right? We're building a very large constellation of satellites to go and remap the Earth in high resolution and, start putting this catalog of updated data of the planet, global remaps of the entire planet in our catalog so everybody can use it for a very reasonable cost. And I think the third thing, or the third, problem we found with mass adoption of Earth observation was just how difficult it is to use, how difficult it is to transform satellite images into valuable insights for businesses, right, or for governments. And we're very excited because we think this is particularly where the newest trends around foundation models, particularly multimodal foundation models, trained on high-resolution satellite imagery, can start opening up very novel ways to engage with a large catalog of data, to extract the insights and to, facilitate essentially fine-tuning applications in very short period of time, right? So I'm sure Maaz will share a lot about what they're doing on the application side, which is awesome. Maybe I wanted to give this introduction to Gerardo so he can show a little bit what we're doing in terms of accessing a very large catalog of data using AI.
Great. Yeah, that's a really good intro into this cool video that you guys put together. It's about 3 minutes. I'm going to share my screen, and I believe Gerardo is going to walk you guys through it.
So to try to simplify how people can access all the data we've been collecting, we put together this conversational application, right? People can access it through APIs. Today, they can access it through a regular web interface, but now we are putting out this soon. So say you're exploring what do we have in the catalog. So you ask how many images for each country in Middle East, and you focus on one, and then you want to see some particular images because you're interested in the dates or places, right? So you build your visualization as you speak to the agent, right? Then you can maybe copy the map to your dashboard, and every time you watch the dashboard, you get updated information. All these images are fresh, well, from the date you're asking, right? From our satellites, all we capture, we process, make available. You can browse, and then you can build on top of this other questions, right? Like in this case, I'm asking about airplanes, and so you, I don't know, the user is interested in airplanes, right? So we build on top of it, right? Then you can not only visualize the results, but you can download them as a GeoJSON, so you can integrate it. So with this, you also build the APIs you can use to retrieve the data, update it, to integrate to your own applications, right? So for airplanes detected, there are a few every month, and I don't know, the user, me, I wanted to see Q2 last year, so I explore and I zoom in. It's interesting because for this particular case, we've been monitoring airports for a long time. So for airports, we usually have a time series, and here you can explore for the different captures how you could say part airplanes move, or whether there's an airplane that's moving. You also get to see that, right? And you can then zoom in to get to see the details, right? And choose the capture, the time you want to see, right? To see, you see overlapping airplanes there detected. That's because there's more than one image on the same spot for the time series, right? And you explore it. So this is it. I could keep building on top of it, or ask about other objects detected. This is a military airport. I live in Qatar, and again, I'm exploring it to see what data is available and whatnot. Right. And yes, and with that icon, you download the data and you get access to the API to get the updated information. I think this is it. There's a lot more to show, really, but I think this is a good intro to what we will be seeing soon, not only from us, from everybody.
Thank you. That was really cool. It's really impressive to see how far this has come in just a year or so. Can you, maybe Emiliano, can you explain the back end on what's happening? So you have data coming in from your satellites, and what's the process of feeding it into the models? Can you just walk us through that?
Yeah, so exactly, it's exactly like that. I mean, our satellites are collecting, normally every day. Today, we're still not using our fleet in remapping mode, but meaning we're not remapping the entire Earth yet on a frequent basis. So we're collecting over targets of interest, over places of interest, and small areas that we're collecting frequently. But very soon we will start remapping the entire planet with our fleet, and then the data is coming into our catalog. Of course, we have the typical processing pipelines, that we use to transform satellite data into, the beautiful images that you get to see, different types of imagery products. But then on top of that, what we're doing is we're applying a number of models to basically enhance this catalog with metadata related to, for each of the tiles that we collect. Our catalog goes into what is called a spatial temporal catalog. So we're talking about very specific, small tiles, 2 by 2 kilometers. Each of these 2 by 2 kilometer tiles then is processed today with a number of models looking for things like airplanes and roads and so on. In some cases, we're processing, and eventually we will process all of these tiles with visual language models. So multimodal foundation models to extract information. We enhance the catalog with metadata. And then what Gerardo was showing is we're using an LLM then to create queries into the catalog, retrieve imagery, right? And then you can go farther and you can use a VLM on top of that to talk, about analyze a specific image, get context, get information about what's on the image, right? So essentially, this idea of an AI-ready or augmented catalog of world data, along with the VLMs to query it and discover insights, we think will help us realize this vision of a searchable planet where you can go and ask, you can see this working already. You can go and ask specific questions like, okay, show me all the airplanes that were detected yesterday in, the north of Ukraine that weren't there a week ago, right? And this is transformed into a number of queries into a catalog. Then these queries transform into the data, and then you can manipulate this data in different ways, right? Like put it in tables, generate output. So this, or ideas that this will help, hopefully, people like Maaz and other people that are out there building applications to create applications significantly faster based on the kind of data that we can collect, right?
Great, thank you. And I want to take a step back real quick on just the industry and where it is. And maybe Alison, you work at NVIDIA, and we can toss it over to you. Can you just contextualize what how NVIDIA chips are used in the general industry, whether it be on board, in orbit, on Earth? What are you seeing over the last couple of years with adoption, how it's being used?
Yeah, so it's really exciting today, especially for me, because I've kind of been prepping NVIDIA for, this, what I call the final vertical, basically. You can look at this problem in two ways. One is the onboard, so embedded compute, so that's in orbit on the satellite, and there are relatively not many smart satellites out there yet, but that's what's exploding right now. Everybody wants their satellite to have some kind of autonomy on board. And then, of course, you've got the massive, data analytics side of what's called the ground segment. So, big compute, and this can be air-gapped military. It can be, our multi-GPU compute for the 100 plus, 200 plus probably different applications, that Maaz can talk about for space data, as we call it. But the onboard is really new. I say nascent. It's actually 2017 is the earliest that I know of. But the way that we actually distribute Jetson, we actually don't know. We can't track it. Jetson is a small embedded credit card sized GPU that has, a pretty cool amount of compute on board. There's different sizings. So it all depends on swap, size, weight, and power of your actual asset. But the way folks are getting into this nascent onboard market is they're demoing, and they have to demo to get proven for the actual, mainly it's government contracts that are funding this. But there's also a lot of VC being thrown into this now. So you start off with a small CubeSat. So that's the sort of lowest amount of autonomy you have. So it's pretty much started with very basic CV. But while this is happening, a very established side of the business is that ground segment where you've downlinked all of the data from your satellite and you can do all manner of kind of, analyzing. Emiliano has already spoken about the VLM. So that's basically just a projection from a large language model, but it's multimodal. It can understand images as well as the actual text. And that, as far as I know, has yet to be demoed on board, but it can be demoed on what we call Jetson on the very low swap. We've basically been doing everything we do is about efficiency. So it's all about how fast can we get it, how efficient, and therefore how small insofar as the compute. So it's very, very exciting, lots and lots happening. But at the moment, it's really the startups that are trying to demo. And obviously that brings in the problems we have with launch at the moment, and the fact that horizontal launch still hasn't been successful. Virgin had a really hard time demoing this, but when horizontal comes in, then you can see that it going exponential, because that's any airport in the world can then start firing into orbit, as opposed to just vertical launch. But of course, SpaceX is doing masses right now with rideshare. Now they're back up and running, which is great to see.
Great. Yeah. And also a reminder to the audience, if you have questions, plop them in the chat. Would love to hear if you guys want to talk more about on-orbit edge computing or terrestrial data input. So just put that in the Q&A.
Yeah.
Maaz, I want to get you in here before we talk. We talked a little bit about that on-orbit edge computing, but I wanted to just talk about what are the applications that you're seeing, what are the needs that customers on Earth with that data are looking for, and how are you guys looking to solve that?
Absolutely. I really love this conversation because I really see that there's something's being streamlined here. Alison's talking about hardware. Emiliano, is really the supplier of satellite imagery. And now this supply is getting more and more accessible through text, as we saw from Gerardo. And now what we're trying to do is try to apply those, apply what Emiliano's team, Gerardo's team, and Alison are basically doing to real life, I would say, scenarios. So one of the applications that I can really openly talk about is really floods or landslides. Those are two big things here, in Switzerland, where we have a lot of mountains, and we need some of those satellite data to come in as soon as possible. And with those new tools, with those new onboard processing options, I think this is going to get quicker and quicker with time. And of course, if we get it to scale with horizontal launches, if we get more satellites up there, if we get those FM's foundation models that I like to call geospatial foundation models when they're huge and they incorporate geospatial data. Once we have those running on top of those satellites, then I'm sure we can have really, really amazing insights to solve real life problems that real people are dealing with on a day-to-day basis around the planet. And one last thing I would add is that it's really amazing that some of those models are, open. I would like to emphasize that Satellogic here has, Earth View, that's super fun, that's out there, and others. There's plenty of them. There's about hundreds of those foundation models out there. And for a startup like us, it's a gold mine. It's really awesome that we can use those new technologies developed by people that are much bigger than us, that have much more capacity, and to get those applied to real life situations.
Great. Gerardo, I want to toss that to you now. There's a question in the chat about if Satellogic uses onboard computing and edge computing, and I believe the answer is yes. And can you just elaborate how I think you're using Jetson, but could you elaborate on how you guys are using it? What's your experience with it, and what do you use it for on orbit?
Yes, we started flying satellites 14 years ago, and since the first one, we had a GPU on board. It wasn't a Jetson at the time. There was no Jetson, Alison, sorry. and so, but with time we evolve. So the main driver for us is we're going to generate so much data on board that download it fast is a bottleneck. Not only because the cost of bandwidth or availability, but fast. If you want results fast, you will want to process it on board. Now that's the reason. If you want to make decisions on board or download, for example, on a narrow band channel, but always available, some alarms. So since the first one, we ship GPUs. We evolve. We use the Jetson's TX2 a lot, and now we are evolving from Xavier to Orion soon, and so we have a lot of compute power. Also, these Jetsons evolve into our platform. That's what the satellite uses to survive, not only for applications on board, right? And then through time we found different uses. So we have a couple of brave customers who want brave enough to give us their code, so we manage it on board, and we pipe through their machine learning algorithms the images we capture, the images they task, not every image, right? So they task an image and a processing. So our is different customers, but mostly they detect things on the images to get as close as possible to real-time alerts. We have many customers that are really worried about the total round trip time from placing the order to receiving the results, right? And for many, we are below the 2 hours. That means place the order, task the satellite, capture, and get the images. And some of them are pushing us to real time through other communication channels. And that's where onboard processing in satellites makes a lot of sense. And we've for these customers, we have a very quick but very good image reconstruction pipeline that runs on board that can reconstruct images in under a minute, which is a challenge, and give users an RGB image they can just process. And we have frameworks on board. So for the more active customer, they send us updates for their software. We manage the updates and run the software, show them the results, they update it.
It sounds like the primary use case, along with it being integral to the entire system for you guys, is for Satellogic is alerts, real-time alerts, being able to detect something, send it down quickly, and have the customer be able to get that. And Alison, I want to. Oh, go ahead. Yeah.
Yeah, that's the main user application, but it's about really bandwidth and communication optimization. So we can choose in orbit whether we want to download or not the image. Say it's full of clouds, we don't download it, or we compress it with the high loss compression, right? So it's about bandwidth and
there's some triage going on there too. Alison, I want to bring you in to hear about any other use cases besides alerts that you see or could imagine in the future with for EO Earth observation customers.
Yeah. So right now, like I said, it's fairly nascent. You know, Satellogic have been going a long time, and the smart side, so the autonomy on board, where you can have, you know, the simple CV, which is like, you know, you can run a cloud mask. So is the cloud, therefore, you know, either discard or don't bother downlinking. So you've got that triage side to optimize the actual downlink, the bandwidth, you know, the amount of data that you're sending down to the ground anyway. But if you know, we're not that far away from actual data centers in orbit. You know, people are now starting to put our small servers. You know, HPE has been demoing for years the spaceborne compute, the onboard in the ISS with our GPU in one of their Edgeline servers. And people are now looking to actually launch that capability. So you can have even greater onboard capability with satellites. And again, the larger the asset, the larger the actual satellite, the greater the swap. So you've got more size, weight, and power, which means that you can put the bigger units on board. When we're talking about Jets and Orin, which is the latest, that's actually only the Ampere generation of silicon. We've already jumped 2 silicon generations since then, but it takes time for space to actually deploy, to do all the radiation and vibration, you know, for launch testing. So there's a real delay between that. But if you just take Orin in this case, the capability for Orin is, you know, you're talking 275 tops. So that's trillion operations per second. And that's when you're talking about autonomy. And I mean, you know, computer vision, for example. So trillions of operations per second that you're talking about. But when you then jump to Blackwell, so that's 2 generations of silicon forward. This is the same capability that you're going to get on board a satellite that you have on board a self-driving car. And the bigger the asset, you know, the more chips you can put on to that unit. And this is what people are starting to realize. You know, I'm dealing with folks that are literally putting together, you know, lunar rovers, you know, large scale lunar rovers. There's at least 3 in contract now with NASA as part of the Artemis mission, for example. But when you're talking about satellites, it's really, really important to understand the capability that you have. We can do so much more, you know, very, very complex artificial intelligence than just cloud maths, or, you know, and definitely VLMs will be the next thing. But I don't know anybody yet who's doing that because this is still so nascent. It won't be long though. It'll literally be months, not years, before somebody's running, you know, visual large language models on board.
Yeah. And yeah, that's a good segue. Can you, Maaz, you brought this up in your intro. Can you define what VLMs are compared to LLMs?
Sure. So a large language model goes from text, or if it's multimodal, it can read other things than text, you know, reports, things like that. So the large language model will translate text into ideally, you know, an output, which would be usually in text. If you're looking at vision language models, those would input images or something that contains pixels. Those images could be satellite imagery. It could be, you know, imagery from a report. And they're going to try to find patterns within the pixels, within the data that this image has. In terms of concrete vision language model applications, what we see the most is a vision language model coupled with a geospatial foundation model which could be, something that's been trained enough, pre-trained enough with thousands of satellite imagery, and then you take that as a basis, and you can train it yourself with your own data. And at the end of the day, you apply it on a real cases, let's say a flood, and then it would give you the flood extent. It would give you the amount of houses damaged, or the amount of cropland that's been inundated by the flood. So, if in our view, if you couple the vision language model to something else, something that's been pre-trained, or your own data that's being fine-tuned, then we can think I truly believe that it can be really powerful, especially if we have onboard capabilities, on the satellite that makes filters the clouds, so that the bandwidth is it's much higher, and you're able to get much more data that's been filtered through. So yeah, definitely a lot of potential, and I think the key word here is accessibility. I think that's really the key word when we speak about vision language models and large language models. It's empowering people to do something that was for them a bit more difficult to do before.
Right.
It's important, I think, to talk about the near real-time aspect as well. So a lot of folks will say real-time, but even a ping of an identification, let's say, of a ship in a certain geographical location, getting pinged down to Earth with today's space comms and telecoms is not real-time. It's going to take a few seconds to even get that ping, and then for that ping to propagate out to the mobile operators, or directly to the operatives that need it, or first line responders. For example, today, military is the only one, defense is the only one that has real-time tasking capability. So you've got to consider that near real-time is the best we're going to get, at least until what's in process right now, which is putting laser communication on board. So that's literally speed of light communication. And that's going to really make a big difference. But it's still that onboard versus the ground segment. The ground segment is still, people clamoring for best case at the moment being about, 5 minutes is a really good result to actually get that, certain imagery down, or even a ping. 5 minutes is good. If you need better than that, you're going to need laser. But anywhere from 5 to, 2-3 days, there is a huge market, a massive market out there for satellite imagery. And all of the other bands, you have to bear in mind, it's not just RGB, which most artificial intelligence models are written for. You can do RGBN, so NAR, near infrared, but there's 16 plus different other channels when you have hyperspectral, multispectral, and that's all really, really interesting data, but it takes time to get that to the customer. And that's really what, it's the race to get to near real time, which at the moment is about this sub 5 minutes is good.
Right. Emiliano, there are 4 or 5 questions in the chat. I don't know if you can see them, but a lot of them are Satellogic specific. Can we do a rapid fire answering? There's some interesting questions in there.
This one, how do you see this new Satellogic LLM solution changing how you enable access to your data? What else would this do to democratize access to imagery? Would be interesting, your thoughts. So I think it's not only us, right? It's not only Satellogic, it's not only the Earth observation industry. I think everybody's trying to figure out, how this new paradigm of LLMs, large language models, will change the way we interact with computers and the way we interact with data, right? And I think the effect is, there's exploration in all different realms of how we're going to do that. In our particular case, we kind of have built our company waiting for this technology to exist, in a sense, right? Like we have been designing our data collection capability or catalog capability to basically to enable this concept of what we call the searchable Earth. And, since 2012, if you want, with the new deep learning paradigms and the things that you started to be able to do in images, and people automating the way we search for cats in Facebook posts and so on, you started to see, okay, this is actually going to be a reality. I think what happened over the last 18 months is, the technology has evolved so fast. And you can now drop a satellite image into, a multimodal foundation model. You can drop a satellite image into Claude Sonnet or into ChatGPT 4.0, right? And you can ask it questions about the image, and it will answer really well, right? And to a lot, and that is extremely new, right? I think the way people will access Earth observation data, for us, it's always been the thought that people will not access satellite imagery directly to derive the insights that they want, right? People don't want to look at imagery, or customers, they don't want to look at imagery. They want to see, the things that they want to see. They want to get the information that they want. We thought, that this is mediated by computers all the time. We thought we would need a large number, or an ecosystem of value-added service providers to take our data and transform it into stuff that users want, right? I think right now what we're seeing with LLMs and with VLMs applied to satellite imagery is that the barriers, or to be able to build applications on top of satellite imagery are coming down, right? The complexity of building is coming down very, very significantly. And it will get to the point where you can sit down in front of an interface and build and design your own application for, satellite imagery, just talking to an LLM, like you do today when you, use Claude or when you use ChatGPT to build applications, web apps, right? So I think this is really the future. I think, the future of Earth observation will be mediated and will be essentially reside inside visual language models. What you can, another way of thinking of this, and I know Maaz wants to jump in, so I'll let him in a minute, but another way to think of this is, a VLM essentially is creating a representation of the world, right? A large language model is creating a representation of the world based on text, based on language, right? It's trained on, books and text on the internet, and it creates a representation of the world that then you can interact with. A visual language model that is trained on high resolution satellite imagery creates a representation of the world through this imagery, and now you can interact with it, right? And that is really what becomes extremely, extremely powerful. So Maaz, I'm sure you have a lot of insights here too.
Sure. Definitely wanted to jump in because we're talking about, those language models and VLMs. And what's super interesting is that there's a question in chat that's kind of, also reflecting on that, is that from Mark, it's, does the new VLM use the VLM or traditional ML methods to extract objects from the imagery? And here I would say that if you're familiar with neural networks, if you're familiar with CNNs, or if you're familiar with traditional machine learning techniques, then the VLM transformer, because it is a transformer at the end of the day, most of them are, it wouldn't be something that's alien to you. But here there's two components that are very important that you wouldn't usually get in traditional machine learning techniques, which are first the text aspect, which is really one of the pillars. And the second pillar here would be the visual aspect of it, the ability to find patterns within data that's pixelized. So this is kind of the things that makes it a bit different from traditional machine learning methods. And to reflect on what Emiliano said, here we're almost talking about making an autonomous, Emiliano said that in the future we're going to be able to build, using this textual interface, build applications. I mean, some of the people are already, of course, on a very early stage doing this. And now people are thinking more and more into going into something more autonomous, what we call autonomous GIS, autonomous Earth observation interfaces, things like that, which are 5 components here that I would like to mention, which are self-generating, self-organizing, self-verifying, self-executing, and self-growing. At the end of the day, this would be, the holy grail if we ever get that. And I truly believe, and I think a lot of people around this table are also believing with the same enthusiasm and same optimism, that at some point we're going to get there. and I can promise you that it might be nearer than what we think.
Thanks. Awesome. And Alison?
Yeah, I just wanted to mention the deployment side. Everything we do at NVIDIA is about deployment, and that's at billion scale, what we call hyperscale. VLMs can already be ran on small embedded compute, much the same as they can also be ran on huge data center scale. And we're capable of providing that. But the interesting thing is that VLMs are very, very new. Again, all of this is really nascent. VLMs are still very new, and from a research point of view, we're still trading the convolutional neural network side and the advantages that they have with the transformer side and the advantages that has. So transformer is very, very quick, very, very, it's almost sort of taken over from the traditional convolutional, the traditional CNN side. But now we're putting the two back together. We've just put out a paper called Mamba Vision, which harnesses both sides. And that, of course, we're doing it because it brings the efficiency, and it brings down the actual compute necessary. It brings down the, that constraint for swap. So it means that you can actually run these things on board. But at the same time, the ground segment is much the same as what you're seeing now. When we talk about LLMs, you're talking about a chatbot. That's the user interface. That's the human, whoever that human is, asking the question, what is going on, in Kyiv right now? Or what happened 2 days ago? Or what's happening in this geolocation? Is there a fire in that? I see literally asking in an English, in English at the moment, or you pop in a language, module and asking in any of the other languages that you may be using. And then that then pulls in the actual imagery that Satellogic have, depending on the georeferencing for that location, and it can look at the actual images, and it can detect, and it can say exactly, because what it is basically able to do is caption, as well as take a user prompt, your question. It's able to caption, and what I mean by caption is literally describe very, very complexly what is in that image. And those images that are being taken in hyperspectral is a huge amount of information. What we haven't got today is a model that is running at hyperscale for satellite complexity, for hyperspectral, 16 plus band complexity of what exactly is going in there. But what we already have is the entire pipeline built to be as efficient, as sustainable, and as low cost as possible. And you can go online and look at Nemo Curator, which basically, helps you pull in the data. We've already built that entire pipeline. Look at Neva as well, Neva. Just, ask a chatbot if you're using them yet, or Google. I pretty much stopped using Google about a few months ago because chatbots are just so much better now. Ask to look at Neva, Neva. To see the kind of capability you get by captioning, where it's describing that. So we've already built the actual pipeline. What we haven't yet done is, because this is so nascent, is have a specific satellite version of VLM. And I see that happening in literally the next 3 to 6 months.
Maybe earlier, Alison. Hera, maybe you can show your screen and show a version of what we can do with the VLM applied to satellite imagery. While I take maybe one of these questions here.
Yeah, Emiliano, I'm curious about that, the protecting the hardware question.
There was a question about shielding. I mean, the answer is both. I mean, it's both software, it's both hardware redundancy, software that is designed so that we can detect and mitigate effects of single event upsets very quickly, and it's also shielding, right? But there's no secret here. But it's the traditional techniques that are used in the space industry in general, right? So yeah, no particular secrets in that sense. Jetsons and are not different from other highly integrated send others. I had this question here that says, Satellogic going to be more of a service or a VAS-oriented company with this AI approach, or only focus on providing and selling data? And then another one on when the API of this capability will be made available. So I want to take this two very quickly. So soon, I mean, we're opening up, basically we will be opening up our catalog, so you'll be able to come in to a website very soon. I hope, we're talking about weeks here and not months, and you'll be able to come to a website, access through APIs. This is something our partners are doing today. So if you are a VASP working with us today, you're accessing our data through our APIs or stack catalog and our visual interfaces. We're going to be opening this up to everybody, basically, so that anybody can come in and do that. And we're also going to be opening up Gaia, which is this demo that Gerardo just showed. So you're going to be able to access our catalog through an LLM-like interface like this and start building these dashboards and so on. Maybe, Gerardo, I don't know if you can share your screen, maybe show a little bit more of what that would look like.
Oh, sharing is not enabled, so
Okay. There you go.
it's not enabled. For the API, we probably first expose an API to access a fresh view of the results you got while chatting to the catalog. So the catalog is an exploration tool to find the data you want. Once you find it, you get an endpoint to get fresh data. So I can share now. Let me see if I can I get to only share one tab. Let me see. Yes. So just an example. I was exploring this here, and I was curious about this one, and so I get the idea of the image and say, please always treat it fine, right? So when they come back, they treat us fine too, Estimate news. Estimate its nearest. Nearest is a way to evaluate the sharpness of the image. It's actually a subjective view on what objects you can see there, right? So yeah, there's lots of things going on, and it's just now I came up with a new question, right? We haven't ever trained on that, right? And so I asked about this particular image. I asked it to analyze it, and then also about the nearest, right? And this is why VLMs are important. When you want to see boats or airplanes, more specific models are cheaper, faster, cheaper to train also, which is important, and more precise than at least VLMs today, to know how many or where the cars are in the image. So for that we train specific models with human feedback and all that. But a VLM is really good when you want to explore and ask new questions, and actually is the only way to have zero knowledge inference on things it's never seen before, right? So we have here the two size bit. This is not dedicated VLM, but it's a really good one, and you can ask things and chat with it. So this is it, right? So people can visualize what we mean when we say VLMs. I'm stopping share. Thank you.
Awesome. That was really cool to see. I love these little presentations. We have 10 minutes left. Again, if anyone has questions, put it in the chat. Maaz, I want to go to you on maybe headwinds or difficulties on incorporating AI into workflow, into Earth observation. Maybe talk about the cost. I mean, all of this, the computing costs and the hardware seems quite expensive. How does a startup, whether it's Satellogic or you guys, manage this in spend?
Right. So there are a bunch of traps that I would like to talk about. A few of them would be that usually what people would go for is that you repackage a language model or a VLM into a domain-specific application. So you use it for satellite imagery, for instance, and that's your added value, or you think that this would be your added value. A lot of people fall into this trap of repackaging something and then using it or trying to sell it. We don't think that this would be the right way to do it. We try, even us, I think you don't hear, we have a saying that you don't make an omelet without breaking any eggs. So we tried and we saw that, this is not what users want, and you have to be user-centric in every single phase of your development as a startup to really find value, and you can only find value if you talk to the users. And with more and more discussions, the applications are very specific. They can be about accessibility, they can be about data fusion, they could be about trying to find the right specific use case, for instance, floods, and it would have to be above a certain accuracy. Your vision model would have to be pretty good. And some of them are actually quite good in some places. If you think about Prithvi from NASA IBM, this one is quite good as well. This one's more of a geospatial foundation model rather than a VLM, but if you couple it with a large language model, it has some nice results. Some other difficulties that you might run into would be data accuracy. Of course, you start with something that's not great. You're not going to get a good result. And of course, the biggest pain point for everyone here would be hallucinations. You have your VLM, it's been pre-trained on thousands of satellite imagery, but now the conditions are different. You're in a conflict area, or you're in an area that has had an earthquake or something that's very specific to the region, then it's going to hallucinate. It's going to show you things that you don't necessarily want to see. And in terms of costs, I mean, if you're a startup, things are going to get very expensive. If you try to get very high resolution imagery, and I think it's something that Emiliano explained it very well in the early stages of our call, that one of the blockers here is the amount of money it costs to get certain very high resolution satellite imagery. And I think it's quite beautiful what the colleagues here at Satellogic are doing, is that trying to make those costs more accessible. And yeah, I mean, those costs are in thousands. The higher resolution you go, the more you have to pay. So one of the advice I would give to people would be, if you're a young founder, if you have an idea, start with open data, start with open source. Start with open data, see if it works, see if it picks up, if there's any value that you can find in there, and go from there.
Great. Yeah, that's good advice. Thank you for covering that. I think we have time for two more questions, or I should say two more panelists respondees. Emiliano, do you have a response there to Maaz? Or also, I want to get to one of the things he brought up, which was accuracy too. How you guys deal with that and think about that?
Yeah, I think, of course, no, that's a really good one. So, look, the reality is the different applications require different resolutions, right? Different types of data sets. For over time, the reality is there's a reason we call a meter, right? That humans call a meter this particular distance and not any other distance, which is, that's really the scale at which we do things, right? And if you really want to see what's happening at the meter scale, just sampling loss, you have to actually sample at least a couple times per meter, right? 2 to 3 times per meter would be good. So I think it's very reasonable that we're looking at resolutions of 30 to 50 centimeters, and say, okay, this is kind of what we need to be looking at to see what's happening in the world, to see the economical activity in the world, to see the stuff that is changing on a daily basis. It's kind of, remember the old saying about, the size of the space station had to do with the size of the horses that we used to carry the carriages in the Roman Empire, right? Because that's how we built our roads, and then the bigger road was the place where we could fit our rockets, and then, whatever, our modules in the space station ended up being sized in that way, right? I think from that perspective, the meter or sub-meter resolution imagery is really the norm, and you have to get there, right? We can't make do with other things, and that's true, right? If you're starting an application in agriculture or in forestry, I would definitely start with Sentinel data, right? Because, obviously data is available, it's open, you can do a bunch of things with it. I think one of the things that Sentinel showed very well is that when you put a data set available like this, people will go and use it, right? People will go and build things on top. And that is fantastic, right? We're trying to do the same thing for high resolution imagery. So we very recently opened up a large data set to help people train foundation models on top of high resolution satellite imagery. We opened up 6 million image snippets in a data set that is essentially Creative Commons license, available for commercial use. So it's, it's really, really widely open and available for people to go and train things. Our goal is to then, on top of that, continue to build on top of that, continue to open up data, continue to open up access to our catalog, so that we can create, a sub-meter resolution version of what Sentinel is doing today for the world, right? Giving access to a huge data set that can be used to build a myriad of different applications on top, right? So I think that's the way we do it. And, to do that, actually, you need kind of, 4 legs to the stool to do that, right? I think we're very well represented here. You obviously need the foundation models. And I think, there's a lot to be said about open source foundation models. There's a lot to be said about open sourcing weights to models. And there's currently an ongoing, if you want, discussion between, things like Llama 3.1 with its new model, which is kind of matching closed models like Sonnet or ChatGPT 4.0. And that's an amazingly interesting conversation that is happening outside of our industry, but it definitely will have a lot of effect. I think over time, we'll see a lot of open source foundation models. In Geospatial in particular, I would mention the one that Clay is building, made with Clay. I think is the website. Clay AI is the name of the foundation model, which they're open sourcing, which is pretty cool. Then you have compute, and Alison here representing NVIDIA. This is kind of, where compute is coming from today, right? And you need massive amounts of compute on the ground to train these models, but then you need the compute in orbit, to be able to process this data in real time. The compute that we're using to instance this VLMs in the ground, and you need data, right? Where we fit is we are providing the data, both the catalog data and hopefully the real-time data that the models will be instanced in. But on top of all of that, you need what Maaz is doing. You need the last mile, you need the applications, right? You need the people that are going to be building the vertical solutions. And those could be, those will very likely use satellite imagery. They will very likely use these models that are trained on that, but they will also fuse other sources of data, right? And they will focus on delivering value to customers. So I think these 4 pieces, or the 4 legs of this tool, I think you have represented here, which I think really good way to think about the ecosystem that we need to build.
Yeah, that was a great way of summing it up. And we're out of time now. It's gone very fast. I know we have questions that have gone unanswered. So I want to go around really quickly for the audience. Maybe just the satellite. Maybe just you, Emiliano, for the Satellogic team. But if you guys can give your maybe email or how the audience can contact you. Emiliano, you want to go first?
Yeah, I think the best way for us, Twitter works, Instagram works. Just look for Satellogic, send us a message. We're there.
Okay. Maaz?
Yeah, you can find us on LinkedIn, ideally. Shoot us a message on Ageospatial on LinkedIn, and we'd be happy to talk to you.
Great. And Alison?
Same, LinkedIn.
Okay.
I will just say, though, that there is a lot of VC out there. So for any startups, I wouldn't worry too much. about the compute side, because this is a very nascent and very big. Climate change is a huge driver of this business. It's not just military anymore.
Yeah, very true. Thank you all for joining. Thank you for being on the panel. Thank you to the panelists, and thank you for the audience who joined. This was very fun, and looking forward to talking again.
Thanks everyone.
Thank you.
Bye-bye.
Thank you.
Bye.